The Faculty of Engineering and Applied Science at Queen's University has been in existence since 1893. We have 2,700 undergraduate students and 550 grad students. The focus of the engineering programs at Queen's is really one of create, collaborate, and communicate. Doesn't matter what discipline you're in, we are really focused on making sure that our students have the opportunity to have real life experience as close as we can possibly get that within the academic environment. The programs within the Faculty of Engineering and Applied Science are all accredited through the Canadian Engineering Accreditation Board, and we have 10 such programs that we jointly deliver with the Faculty of Arts and Science. These come from both the traditional disciplines, mechanical, civil engineering, chemical engineering, electrical and computer engineering, as well as we have 4 engineering science programs which tend to focus a little bit more on the theory and are unique programs to Queen's.
Queen's Engineering is quite unique in the way its program is structured. Students come into a common first year, but the unique thing is that they get a free choice of discipline going into their second year. Students come in, and at that point they're doing all the basics that we think are really important for an engineering student to know. So all the basic physics, chemistry, math, that kind of thing. In addition, we have found from industry that what they really want is our students to also be able to communicate that information when they're out in the workplace. And so we've initiated a professional skills spine in our program where students right from the first year will learn about how to design, how to work in teams, how to work on projects, and how to communicate your results across to others.
The purpose of the professional spine is to give students a chance to develop the kinds of skills they need as engineers to emulate professional practice. The first year of the design sequence is to give students a chance to apply creativity, to work on teams, and to integrate technical skills with professional skills. So the students work on 3 modules, one of which is complex problem solving, where they are working on small teams on things that are as close as possible as we can get to engineering activity. Once they've done that, in the second semester they move on to team-based design projects where they're working with clients, real clients from the local community or from on campus, and the students would work on solving problems for that client, developing the ability to communicate effectively with the client, and also developing the ability to work with realistic constraints.
My favorite element of the course is probably having the opportunity to apply our skills. For example, my project was designing a set of accessible musical instruments for the Hart School in Kingston that will hopefully be used by people with special needs. I feel that this integration and participation is so necessary towards our degree because an engineering degree is an applied degree. We need practice and we need to be able to use it in the real world once we graduate.
By definition, engineering is a creation of artifacts to fulfill a need. They fix something, they correct something, they make something work. As a result, they have to have a process to do that. Our goal is to give the students an opportunity to really understand design process, but moreover, how that design process integrates with and is dependent on the real professional activities in engineering. So things like communication, project management, engineering economics, societal implications. Many of our partners will say that the students they hire from our program are typically at least a year ahead of most engineering graduates they hire. They truly do hit the ground running and they're able to start achieving and producing in a much shorter time.
Queen's Engineering has always had a very strong record of student support. And in the last few years, we've qualified this or quantified this into our 10-point student success model. These points include everything from J-section, which is the opportunity for students to actually rewrite exams and do courses over again in winter, as well as we train some of our third-year engineers to be peer counselors for learning skills for our first-year class. So they work one-on-one with our students.
Our community is unlike any other. The support here is the most amazing thing that you'll ever experience. When you come here, you feel like such a part of a team, and you really do work in a team.
The community here is great. Everybody's so friendly. You're able to get help from professors, from other students. Everybody's so incorporating, and it's a great place to be.
We started up an Aboriginal Access to Engineering program about 3 years ago. And what we do here is we support Aboriginal students through their education, and we encourage through outreach Aboriginal students to think about engineering as a career.
Queen's Engineering is very successful at graduating its students. Our graduation rate is about 91%. Our employment rate's around 94% for our students because we not only focus on giving our students a good academic background, but also a very strong basis in professional skills, which helps them really hit the ground running when they get into the workplace.
Queen's University does have an academically challenging program, and it also has wonderful spirit. And so the key to success here is to collaborate. We enable it, we help it, we support it. With the spirit that's here at the university and the support systems we have, we really focus on student success.